Hello, today I'm going to do a demonstration on cross products. We're going to understand how to decompose them and we're going to analyze them. We're going to need to know basic vectors, and in this purpose I'm going to show you how you can actually use a container, with a removable cap to actually understand vectors, the vector process. So let's actually go right to it. So in a vector is always made up, remember, of a magnitude. So vector is always made up of magnitude and, of course, of its direction. Now, if you're taking physics, the magnitude is actually not that hard. You would actually know that vector A cross product vector B is actually equal to the magnitude of A times magnitude of B times sine of theta. Now, this formula might not look intuitive at first, but it will. For now, you just have to know that A cross product B is not the same thing as multiplying, because although A times B in multiplication equals B times A in cross products, vector A cross product B is not the same thing as B cross product A. Alright? So in this video we're actually going to be concentrating more on its decomposition and then direction. So let's actually start. Any vector, such as for example vector A, is made up of smaller parts of its x and y components. For example, if we have some vector in the x and y plane, let's call it vector z in this case, just for reference, as it's not part of the z-axis. So we can also decompose it into its x component, and we can decompose it to its y component. So if you see, every vector has and will be composed of these smaller chunks. Now, knowing these smaller chunks is very useful, so let's actually go to it. I'm going to write the general case of vector A. I'll write, let's say, AX. We're going to use the notation for vectors. This is I caret plus B. Actually, I'll just keep it A and then Y. So what I mean, I'll explain right now. This A, Z, K. So pretty much, this means x-axis, or x component, y component, z component, and these symbols are just customary to write them. It's like writing AX, AY, AZ. All right. So this is the x portion, y portion, z portion. This makes up a typical vector. All right. So now, if we're going to do the cross product, let's say with a different vector, B, I'm going to decompose it in front of you so we can analyze it. Bx, if you see, they're all made up of just different numbers, but of the same idea. Now, what are we going to do? We're actually going to do this. A cross product B. So, the main goal of this right now is using these two parts, and we're going to decompose them. So let's actually go to it immediately. Okay. So A cross product B. Oh, sorry. It's cross product. I always get confused with this scalar product. So A cross product B equals, we're going to substitute what A was. AX I caret plus AY J caret plus AZ K caret. Alright, we call them caret because of their notations in their head. And this is going to be multiplied, the cross product times the following. Bx I caret plus by z j caret plus bz k caret. Alright, so we're going to have to multiply. But you can actually think about this slightly like if it was distribution. But before we continue, let's actually show what this I, J, and K caret is, or are, my bad. So so it's just a way of saying X, Y, and Z. For example, here I'm going to call my X-axis, this is my Y-axis, and this is my Z-axis. Alright? Now this is pretty easy to understand, but now we denote them in the following way. This is I caret, this is J caret, this is K caret. Alright? So I caret is just X, J caret is just Y, and K caret is just Z. So let's get right to it. So we have both of these vectors. Now, when you're going to do the cross product, you're going to want to multiply it in the following way. At least I do it like this. I'm going to multiply this times this, you know, customary, like we've always done. We're going to distribute it. But it's just distribution, but all you have to do is take a little bit more care when you do it. For example, we're going to distribute the first part, ax times bx. Alright, I would like to get the coefficients together first, and then their direction notation. I caret times I caret. Alright, then we'll continue. This bx times this. So that's ay times the coefficient bx. And then, of course, we have to write it in this order. J caret, because remember I told you there's a difference. There's j caret, and here it's I caret. Alright, then the last part is az times bx. Here we have k caret times I caret. So this is going to be the first part. Now let's actually I'm going to expand that right now. So right here, ax times bx, this already tells us what the magnitude of that component is going to be, but we actually don't know the direction. What does I caret times I caret mean? What does j caret times I caret? Well, what do all of these things mean? Well, I'm going to draw actually a bigger case of this z and x and y axis. So this is a z, this is the x, and this is the y. We're going to get customary to write the following now. Okay, sorry, k. You can see I'm not even used to it. Well, now I'm going to use this bottle right here. Now, for example, when they say let's say k caret times I caret, the way I think about it, just think about x and y. So forget about this I right here. We have this x and forget about this j. We have x and I. So we're going from x to I. We're doing this case right here. Okay, we're going from k to I. Right here it says k to I. We read from left to right in this case, k to I. So now what I do for the following cases, I get the bottle. Okay, I hold it in that angle. So for example, this is my k, this is my I. All right. So we're going this way in the counterclockwise. So this arrow says counterclockwise. We're going to go counterclockwise. I'm going to remove it. Now what happens? It goes up. You see? It goes up when I pull it. So when you pull it up, what axis are we on? Exactly, this part. We're on the j-axis. So if you're going up on the j-axis, you're actually positive. So ki is actually j-axis, and it's positive. Az bx. Alright? And we do the same thing for the other ones. Let's say j caret I caret. Right here. J caret I caret. So again, just think about j caret and the I caret. We're going from j to I. Alright? So just imagine that plane in your bottle right here. Alright? Okay? So the first thing we're going to do is spin it. Here it says clockwise. So we're going to spin it clockwise. And you actually see it gets tighter and tighter and tighter. We can't move it. So you're actually drilling in. Okay? So actually this is going to be k. We're in the ji. We're going k, but we're going down. We're drilling in. Alright? So this is going to be k. The only thing is that it's going to be negative ay bx. Then the last part, ax bx, I caret. Now the a very important part about this is that when you're in I caret, so we're in the we're in the x-axis and we don't move. Now, what does that mean? Well, if we don't move, there's no angle. Angle is 0. So here, what's sine of 0? Well, that means that the magnitude is 0. That means that this simply equals 0. 0 times ax by equals to 0. So from the first expansion, we're left at negative ay bx is in the k direction, plus az bx is in the j direction. So we've only done the first third of the expansion. Let's actually continue. Okay, so we've expanded b already. Now we're going to expand by. Okay, so same idea. Here, here, and here. First it looks tedious, but after you do it a couple of times, you actually get very used to it. So we write a x, remember by, in that order, times I caret times j caret. Okay? Next we go plus by times, okay, sorry, this order, remember, ay by, here j factorial, j caret and times j caret, alright? Then the third part, it's plus az by k caret j caret. Okay? Same idea. Now we're going to analyze these three parts before we join them. We're almost done. We're 2/3 done. So, like, we've seen this j caret, if we look back into the graph, there's going to be no angle. As we've seen sine of 0, this is just going to cancel out. We've seen that pattern already. But let's actually go to k and j. Let's actually go into k caret and j caret. What is this telling us right now? So, think about the k axis and think about the j axis. So we're going from k, then we're going to j. Alright? So think about that plane like this, and it says we're going clockwise. So actually, if you're going clockwise, you're actually tightening it. Because if I want to go counterclockwise, I actually can take it off. But I'm not. I'm going in, and I'm tightening it clockwise actually. Alright? So because it's getting tighter, I'm actually going and I'm drilling in. Alright? So because I am drilling in, this means that this is going to be I caret. However, because we're drilling in, it's going to be negative. Negative a z by. Alright? So now let's do the same idea to ax and by. Right here. And we're just going to imagine the I caret and j caret. Now, we go from the left to right, because that's I to j. So we're going this way now. Now, you imagine that plane, like this. Okay? So, here's I, here's j. We're going from I to j, so we're actually going to go counterclockwise. And if you go counterclockwise, you see that the bottle is removed. The cap is removed. So if it's removed, you go up, right? So that means it's positive k caret. So you write, this turns to k caret, and it's just positive. Alright? And we're done with that part. So, we're going to have to do one more. Let's go right to it. So right here, now we just have to expand the BZ. Okay? So, in the last part, I'm going to go like this. Same idea, just BZ times AX, BZ times AY, BZ times AZ. In that order. Make sure it's just like distribution, and the only thing is that you have to be a little bit more tedious about how you distribute it. So always AX to the left, BZ, A caret in that order, and then times K caret, the one we're interested in. Then we put plus, we write AY left, and then we write BZ. Then we write J caret, K caret. Then the last part is AZ, BZ. We get K caret, K caret. Now, when you're doing this, and you actually get pretty glad when you see the same carets, because you know they're going to cancel out. So let's go immediately, and we're going to cancel them out. Hopefully we understand already that this thing equals 0 because there is no angle between them. And now let's analyze these. I'm going to make one more. Just one more. Okay, so this is K caret, I caret, this is J caret. Okay? So here we say J caret to K caret. So we go in that order. We start at J caret and we go to K caret. Okay? So because we're going in that order, think about that as a plane. So this is my plane. This is J caret this way. This is K caret. We're going from J to K. So we're going to go this way. And you see, it comes out. So because it comes out, we're actually going to have a positive I. So this thing right here is going to be positive I, AY, BZ. Okay? And the last one we have to do is I caret to K caret. Alright? So we start at I and then we go to K. Like that. So we use our bottle one more time, like this. This is the I, and this is the K. We're going this way, and you actually see that you're tightening it. It doesn't bulge. So that means it's negative. Because you're drilling in. Instead of coming out with a positive K, you're drilling in. Alright? So AX, BZ. It might not, I'm pretty sure you cannot bring a bottle to the exam. But if you're a beginner and this is your first time doing it, it's very useful. Well, we're almost done. We have already our components. Now we just have to join them together. So let's see. We have a J caret, I caret. Then from the previous ones we did I caret, K caret, and then we have the K caret, J caret. Let's actually join the I carets first. Okay? So I write I caret. So here we have AYBZ, that's the first term. BZ. And which other ones has the I in it? Oh, right here. Right? This has an I. We can factor out the I caret and we'll join this together. So that's minus AZ BY. That's the I caret term. Now the next term of interest is the J caret. So here we start out with the positive. This is the J caret right here. So I write plus AZ BX. Okay. Now where's the other J caret term? Let's see. Oh, right here. So we write minus AX BZ. Okay. And they all have a J caret, right? Perfect. Now the last term is a Z caret. Well, no Z carets here. Let's see where we have a Z caret. Sorry, K caret. Let me check again. Here's a K caret and here's another K caret. So let's start with the positive first. Plus AX BY. And here's the second term. Minus AY BX. This is the K caret. So this equals, all of this actually equals A times cross product B. Now, why is it so long? Well, because we did a decomposition assuming there's 3 sides. I'm saying it's composed of three parts, X, Y, and Z. Now, in most advanced physics classes, you'll see that this actually is actually very useful. It's very tedious to memorize. I actually don't memorize it. I actually redrive all of this. With practice, it actually becomes very fast. Throughout a very fast process. Hopefully you've seen that the bottle actually helps you. I don't know if it's coincidence that they designed it to oblige by that rule, or it's just a coincidence. But if you want, you can use that or the right hand rule, whatever works for you. But I just wanted to show you this perspective. Thanks.